Thank you, Alexia. Hi, everyone. Welcome to my talk. Thank you for attending. We're going to be talking about the secrets to reducing cloud costs. We'll talk about identifying your costs, exploring your alternatives, and some trade-offs associated with those alternatives. And just like there's too many words in this title, I have too much content in my talk, so I'm going to be cutting out a couple slides towards the end. I'll be summarizing them. I'll be posting my full slides on the Bitovi Discord, and also if you want to do a Q&A, I'll be out in the hall, or you can find me on the Bitovi Discord to answer any questions you might have. So first, a quick intro. Who am I? Like it was just mentioned, I'm a back-end development manager with Bitovi, and I've been there for 9 years. We've done temporal consulting for Yum Brands, the world's largest CDN, world's largest pharmaceutical company, and several startups over the last 2.5 years. Some of those newer clients, we don't have marketing agreements yet, so I'm going to be a little bit vague. But I also spoke at Replay last year, and I think I see some people in here who were in my Temporal 101 and 102 using the Java SDK earlier this week. Thanks for coming. So it's a little bit earlier for Halloween, but let me lead off with a spooky story. Please put yourself in the shoes of a temporal expert for your department. You wake up early, it's cloudy outside, it's a Friday morning before your vacation, but something feels off. Something's not quite right, and before you know it, you hear your phone going off on your nightstand. You look, and it's an invite to a 9 a.m. meeting, and it's titled Urgent Cloud Budget Overrun. So you know that there's going to be a real treat of a meeting coming up for you, and you haven't even read the description, and you probably know what your boss is like right now. The money is on fire. The management needs to find someone, anyone, ASAP to help save it. The invite explains it's department-wide. Someone did a typo when talking about the budget, and now everybody's got to tighten their belts and find some cash. So your mission, because you've been added to this meeting, you know it's going to fall to you to optimize your temporal cloud costs. You know that to make your boss happy, you're probably going to have to find about 10 grand to go on your vacation and not get any emails. But the silver lining is that you're going to save this exec's bacon, and you're probably going to get that promotion that you have your eye on for year end. Because you've seen this talk, you're going to think, no problem, I've got this. You're going to put on an extra large pot of coffee and respond, don't worry about it. This is you, and I guess your coworker getting ready to slash some costs. The department is in great hands. So your targets, because Temporal Cloud has pretty simple pricing, is actions, actions, and your stored history data, your stored event history. You really just have these two costs to worry about, and actions are fairly affordable. $25 per million actions, and actions starting a workflow, starting or retrying an activity, sending or receiving a signal, receiving a query. There's several other behaviors that cost actions. There's a full list online. But the overall picture is that actions are quite affordable. You need to be operating at a fairly large scale for this to become like a cost center that you have to start worrying about. Much more frequently, people will find themselves with unintended costs around event history data. Temporal records this complete event history of everything that propels your workflow forward. This can unintentionally become quite large. So when you're writing your workflows, you want to try to write them so that you can move them from this active storage into the retained storage as quickly as possible. It's 100 times cheaper to keep something in retained storage. It's billed per megabyte hour, but I put it into these so you can just kind of get a better idea of long-running workflows, what your costs are going to look like. You can eventually, shift this to the retained storage, and we'll talk about a couple ways to do that and save some money. With these costs in mind, the approaches are pretty simple. You need to reduce your action storage, or reduce your active storage, change what you're storing and how long you're storing it, and trim your action usage, using fewer activities and signals to try to get the same work done. So we're going to talk about a couple approaches to this, but first we need to note there's always a catch. Every optimization has some trade-offs, and this is no different. Temporal comes with reasonable defaults out of the box. It's not like it's set up for you to need to optimize it immediately. They've tried to make it so that the familiar approach you have for writing procedural code is often a good place to start. There's very few gotchas waiting for you. So it's not a bad idea to start with a somewhat naive approach. In a lot of cases, that's going to work out just fine. But if you're operating at a high scale and you're looking to save some cash, when you optimize, there's going to be a few trade-offs. Typically, it comes with maybe some increased latency. Your activity needs to load some additional state because it's no longer receiving it as part of its payload, things like that. Some increased complexity, maybe what used to be one workflow is now split up into 2 workflows, or one workflow now has additional executions. And there's just some mental overhead to understand like the model around why that is, and then like analyze it appropriately. So there's a little bit of increased complexity. And with that, you have to understand that increased complexity if you want to observe it. So the observation becomes a touch more complicated. So the first kind of way that we'll talk about saving money is this active storage. And customers often find that they can save money on storage, so that's where we're going to start. Customers are frequently storing more data than they need, storing data longer than they need, and luckily the solutions to that are pretty easy. The frequent optimizations we see people implement are condensing their payload size, limiting their history length overall, and in particular, segmenting, limiting their history length before they do a workflow sleep. And we'll talk about why that is a particularly good scenario. So condensing payload size overall, temporal payloads can be up to 2 megabytes. That is the max size that you can pass into a workflow, pass into an activity, pass out of an activity. And you have to be especially careful with data that's going to be passed around repeatedly. If it passes into a workflow and then into an activity and out of an activity, that's 3 times I'm passing it. That's 6 megabytes I'm potentially adding to my workflow history. And you never really want to be near that 2 megabytes if you can help it. Again, you're bloating your history quickly. There's max limits on how large that history can get. And so you want to keep this low just so that you keep those costs low, as well as when you're sending your messages around, when you're actually processing temporal behavior, those messages that you're sending around are smaller. You have higher throughput and lower latency because you're just passing around less data. So yeah, in this example that I've got, and all the examples I've got are going to kind of be based around road traffic scenarios, because who doesn't love a car analogy? And just imagine you're working for a Department of Transportation and you've got some sort of workflow that is processed every time an accident that the department needs to be aware of occurs. So you're scanning some sort of paper report and then submitting that report into your workflow. 10 kilobytes might not sound like a lot, but if this is going to be a long-lived workflow, if there's thousands or tens of thousands of accidents happening, you really end up storing a lot of this in your active storage. And the temporal active storage is essentially in memory, so it's accordingly expensive. So there's a couple ways to avoid this. Either you just pass in less of this report that you've OCR'd, just pass in the parts of the report that you need. Or if you need to pass in the whole report, there's kind of 2 broadly applicable techniques. And that's either passing by reference, giving a reference to where you can find this data later, or compressing your payloads. Yeah. Compression, not very glamorous, but still a very useful tool to have in your tool belt. So we'll talk about pass by reference. And really what you're doing is storing your data in some outside data store, in this case S3. When you receive this OCR'd report, you upload it to S3, and then you start your workflow. But what you provide to your workflow is the S3 key. And then when you have some sort of activity that needs that data, it'll fetch it as needed, make any transformations, save it wherever it needs to be saved, and finish its activity. This allows you to pass around large pieces of data without having to worry about the storage costs in your workflow events. Really, you can only need to do this with your oversized bits of data. You don't need to pass everything into S3. But really, you should reconsider what you think of as oversized if you're going to be running tens of thousands, hundreds of thousands, millions of workflows. And then the next approach, a little bit less exciting, but equally important, is compression. If you have some text that you've received from a user, why not compress it before you send it into your workflow? It doesn't take very much for your activities to unzip something. It makes it a little bit harder to debug, because now when you're looking at your payloads, you might need to unzip something. But really, it's a perfectly applicable technique, and you shouldn't leave it on the table if you're looking to save some money on your payload size. And if either of these approaches sound good and you want to apply them across all of your workflows, an approach that you can take is using the data converter. So the data converter is an approach, or is an interface that Temporal offers that allows you to apply transformations to the payloads you send to Temporal. So that transformation can be encoding it, or it can be uploading it to S3 on the way in. And then when your worker picks up that payload, it can download the payload from S3. And in this way, you can kind of pass around arbitrarily large payloads, and really you're just paying like the latency costs and like the storage costs associated with keeping this in S3. You're also adding another dependency to your distributed system. So if you really don't want to depend on S3, then this might not be a great approach. And instead, you might use the data converter just to do encoding. So you could zip up instead of uploading to S3, and then your data encoder on the worker could unzip transparently. So in this case, you wouldn't have to implement that in your activities. The temporal client will do it for you transparently as you use temporal. This data converter is also frequently used to do encryption and decryption so that your data within temporal is encrypted when it's stored at rest. That's one of the most frequent applications for this interface, but you can also use it for cost savings by uploading or compressing. And the cost savings can be pretty significant. If you had 1,000 reports a month and each report ended up with about 10 megabytes of history, and each report took about 6 weeks for the workflow to complete, if you offloaded all of that into S3, that's about $5,000 a year that you could save overall. And I just want to touch, don't forget about signals. Signals are payloads too, so when you're messaging into your workflows, that also gets saved to the event history. So yeah, it's saved there for the whole life of the workflow. You want to kind of do the same things, pass references into your workflows via signals, compress your signals, and if possible, try to send fewer signals overall. Batch your signals, deduplicate your signals at the service level, filter for relevance if applicable. And then the other technique for keeping your active storage costs down is limiting the history size. Long history can be unavoidable. This is the product of your workflow. If your workflow is complicated, you're going to end up with a long history. There's not a lot you can do about that, but what you can do is figure out how long you're going to store it. So if you're doing a complex workflow that's looping, has many activities, especially if it's going to live for a long time, you want to think about how long you need to keep these events around. And the way that you can proactively decide, I want to send some events to the retained storage and keep myself running, is by using continue as new. So continue as new, just to show it in a diagram, is when a workflow proactively checks its own conditions, either checks its own history length or decides I'm at this point in my process. It's a perfect opportunity for me to continue as new. And continue as new is when you kind of export the current state. You capture the current state of your workflow into something that you can pass into a new workflow, and that new workflow will know where to start. And by doing that, you can end all your existing event history, put that into storage, start up a new workflow that is essentially starting up from the same point, but has a fresh event history. You're no longer paying for storing that old workflow. And there's kind of two classes of this type of await that I'd like to touch on. One, where if you're awaiting a signal, if you're awaiting a user to send in something and you're deciding to go to sleep, there's one approach you can take. And another approach that is more appropriate if you're awaiting a timer, if you need some sort of temporal scheduled timer to come back and wake up your workflow. The two techniques I refer to as resurrecting a workflow and continuing as new prior to sleep. Segmenting your history before sleep. This is the accident report workflow we saw earlier. So if we imagine it's been running for a while, we've gathered all the details we need, we've generated some legal documents, and now we need the legal department to review them. So we're awaiting a signal here from the legal department. Some lawyer has to call in. And maybe that's going to take several weeks. We don't know how long it's going to take for the lawyer. So why are we keeping all of this event history that we have around for the whole time? So we have this event history that's quite long by the time that we hit the point where we need to await the legal department. And what we can do is say, okay, I know where I am in my workflow. I'm going to communicate that to a new workflow. I'm going to give it the context it needs to know what report it's operating on. And then that workflow can immediately go to sleep with almost no history and very little cost associated with it because it has a small history. And it can do the awaiting for you and pick up where your other workflow has now ended. So yeah, this is the continuing as new. Doing this prior to sleep is always a good idea because you have this big workflow with all of this history around it. If you're going to be sleeping for a while, why keep that history around? It's a perfect opportunity to spend a couple actions and take this opportunity to start a new workflow and save yourself on the action storage, or the event storage. Then, yeah, the resurrecting workflow technique is if you're interested in taking this a step further. The prior technique is what I would recommend most of the time. It's a little bit simpler. But in this case, instead of continuing as new, that same state that you would send into the new workflow, you could instead save to Postgres. And then there's a signal with start behavior that Temporal has. So then when the lawyer signals in saying, hey, your papers are approved or your papers need to be amended, that will actually wake up the workflow. So that will start a new workflow with the signal with start, and that new instance of the workflow could know based on that signal, hey, I might have a saved state in the database. It can find that saved state, resume from that saved state, and process the signal and resume accordingly. So this gets your costs down even lower. You have nothing waiting in Temporal. You just have this saved state in Postgres. So you can have millions and millions of workflows not costing you anything on a day-to-day basis, and then when someone signals in, you can wake them up and continue with their behavior. The limitation here is that, yeah, if you're awaiting a timer, this isn't the best approach, because now your timer has to come from outside Temporal. And yeah, if you're waiting a timer, something like waiting the filing date for these papers, you're waiting to see what the other lawyers have contributed to the case, and you're awaiting this date, it would be best just to do a normal continue as new, so that you can use the Temporal Cloud timer functionality. So yeah, these two approaches, resurrecting is a little bit more aggressive, but it's really only for cases where you have lots and lots of these sleeping workflows. If you're just doing normal amounts of sleeping, I would suggest the early one. It's a little bit easier to implement. And you're not adding another dependency. You're not bringing in an outside database that you need to depend upon. The cost savings here can be pretty significant. If you had, again, 1,000 accident reports a month, and let's say each accident report had about 2 megabytes of history by the time it was going to sleep, and let's say on average it sleeps for about 6 weeks, that's $1,000 a year in storage costs that you were paying for sleeping workflows. So and again, that's on a pretty small case, just 1,000 accident reports a month. So those are the techniques I want to talk about regarding active storage. We're going to move into talking about the action storage. The action costs. And with action costs, again, kind of like your workflow history, if you have a complicated workflow, you're going to have a lot of actions. It's just kind of unavoidable to a degree. You need a certain amount of actions as a baseline just to implement your business logic in an idempotent way. Often you implement something in the obvious way, and usually you're not more than an action or two off of the most efficient way you could do it. So you're usually just squeezing an action or two out of your workflows. It's not like you're going to find a way to split half of your actions off of your workflows or something like that. And all that is to say is that it's much less likely to incur accidental high action costs and much more likely to accidentally find yourself with high storage costs. But yeah, if you are running lots of workflows, you might have some optimizations available where you can save a couple actions. So you can take advantage of batch operations. This is something that people kind of unintentionally find themselves missing out on. You can prefer parallel activities to child workflows. You can limit the interactivity of your workflows and leverage local activities if it's a good choice for your workflow. So the batch operations, this is something that we frequently see people doing. It's generally completely unintentional. Temporal gives you this nice way of structuring all your execution flow and your logic on a per entity basis. You can have, in this case, a kind of toll road auto billing workflow. Someone drives past a camera, we bill their toll road account. And so this is running tens of thousands of times per day. You debit their account, you send some notifications if they're running low on cash in their account. Maybe you send a reminder that they're overdue, something like that, and then you archive the photo. But you're doing this tens of thousands of times a day. You want to archive this photo so if somebody complains or you have the photo somewhere, but you're doing it immediately, when really there's no reason you couldn't do this on an hourly basis. You're not going to be filling up your storage. You don't want to keep them in the same bucket forever. Another team manages the the archive, but you don't have to move it immediately. You can use maybe the S3 batch API on like an hourly basis and turn what might have been tens of thousands of actions because you just happen to do it in a per entity basis, but you could offload it to another workflow, and really it's just a little bit more complexity. You're introducing this other workflow, but you end up saving tens of thousands of actions per day. And in this case, like I'm kind of illustrating that we know some way of querying the debits, and based on that querying of the debits, we can decide what to archive. I note that because you do need some sort of outside reference. You might think, oh, well, I'll have my auto billing workflow signal into my cleanup workflow, and it'll use those signals to decide what to clean up. But sending those signals costs an action. So unless your cleanup workflow is going to save you multiple actions, you're kind of just breaking even. So to do this, you either need to save on multiple actions in your cleanup workflow or have some sort of outside reference of what you're going to be cleaning up. So yeah, you kind of need the right scenario, but this can be a great way to save on your action costs. Yeah, like I said, it's saving an action for each time you do this batching. Let's say that this was toll road transactions for New York State. I managed to find this. They do 375 million transactions per year. So that's about $25 per day just in transactions. It would come up to over $9,000 per year saved just by moving this one archiving outside of that workflow. So when you're writing these really high flow workflows, it would pay off to think about what do we need to do and what can we do less frequently. Moving on to this other topic, parallel activities. Every time you open up a child workflow, that costs 2 actions. It just has some overhead associated with it. So if you have a child workflow that, hey, it's nice to run this on a per child basis. Again, it's nice to model this on a per entity basis. It might make sense to, if your workflow is simple enough, pull that up into the parent. And so you have maybe this traffic camera health check, and you have to go through a bunch of cameras, and each one needs to be checked for health. But they all do the same checks. And really, it's just a pass or fail. Like if the camera fails the health check, you need to send someone out into the field to actually go tinker with it. So there's not a whole lot of remediations you need to do. You can instead pull up these checks into the parent workflow and just batch it out, check all the cameras, pan, tilt, zoom behavior, check all the cameras, heater is working, and just kind of do that as a series of batched activities and save yourself the overhead of starting up all these child workflows. There are a little bit of some downsides here, like the suboptimal pipelining. You now don't have like separate execution flow for each one of these cameras. So if you're doing a batch of these checks and one camera could have moved on to the next check, it's waiting for all the cameras to finish. You're doing them as batches, so you're maybe not completing the health check for each individual camera as fast as it could be. So a little bit of a overall latency trade-off for just how long it takes to complete your workflow, but you end up spending far fewer actions over the course of the workflow. This can limit your complexity. If you're pulling this data up into your parent, you don't have that separate thread of execution for each of the entities now. So if you have complicated retries or you've got diverging code paths, and it's not just a simple pass or fail that you're trying to do in this child workflow, it might not be a good candidate for this approach. You might need that separate thread of execution, that separate actor to capture the behavior of your child workflow. And because you're pulling up these child workflows into the parent workflow and you're trying to get everything done with activities in the parent, you are growing the size of that parent workflow. So now it becomes imperative that you use that continue as new technique to keep the size of this workflow down. But yeah, as I mentioned, you're saving 2 actions per workflow. Again, another little toy example, if this was for New York State, they have 23,000 public traffic cameras. If those were checked 2 times a day, 365 days a year, that's 34 million actions saved, so just about $850. This one I'm going to kind of breeze through just for the interest of time. I'll summarize it. This is just limiting the interactivity to your workflows. Again, trying to batch the signals into your workflow if possible, deduplicate and cache queries, and maybe filter for relevancy at the service layer if you can. Every time you are interacting with your workflow, you are incurring action costs associated with that. So unless your use case needs it, you should try to reduce the amount that you're interacting. Make sure it's relevant to your use case. So I'll skip over these slides. They're not quite as interesting as this last one, which is leveraging local activities. Local activities are activities that are run as part of a workflow task. So this is a bit of a optimization. It's efficient and low latency, but you lose out on a lot of the niceties of a normal activity. You don't get the queuing, the routing, the rate limiting, or the flow control of a normal activity. So really, I would encourage you only to think about these as an optimization. Try to do whatever you're doing with normal activities first, and then if you notice like, oh, we need lower latency, this is a bit of a cost center for this, we're doing this so frequently, maybe then you could consider local activities if you're matching these other criteria. If you have a very low latency activity that you're trying to move to a local activity, if it's very frequent, you're calling it in great quantities, and ideally if it's very reliable or something that you can kind of, if it fails, you can continue on your happy path. It's a best effort delivery. So kind of an example would here, again, moving back to my car examples in this auto road billing API. So if you scanned, you might want to say, oh, this person drove past this toll road. You might want to emit an event, but it's not for your own internal usage. You're trying to do a best effort delivery to third parties. Maybe insurance companies want to know how much people are driving, so they're going to get this data from the government. It's a best effort delivery, and you're sending a bunch of them, and they're usually low latency. Maybe you're updating DynamoDB, or you're sending something onto a Kafka topic. In that case, it would be a perfect opportunity to use a local activity, handle all of these events that you have to emit as a single action, and just kind of have some savings and some efficiency there. But generally, again, this is an optimization that I would recommend after trying normal activities. So that kind of summarized the means that I've set out here to reduce active storage and trim your action usage. One other one that I frequently get that I'd like to touch on, it's often asked by our clients, it's like, can we save by self-hosting? And usually my response is that like SREs are expensive, especially ones who are going to be like good temporal maintainers and temporal SREs. And when you're setting up temporal, there's often 6 or more instances that you have to set up in a production environment. You have to figure out how to scale those. Sometimes that can be somewhat subtle. The bottlenecks within temporal can sometimes be subtle. On the other hand, Temporal Cloud is cheap. Especially at human scales, $25 per million actions, you're going to have to do a lot of things if you're just like a small company with tens of thousands of customers before you hit so many millions of actions that it's going to become a concern for you. So if your company is operating at human scales rather than system scales or platform scales, oftentimes it's not even in the ballpark. And if you are operating at those system scales and those platform scales, some of these cloud cost optimizations I've talked about today are usually a much easier way to squeeze those costs and find a way to make it work on Temporal Cloud. There are legitimate reasons to self-host. If your organization, if you need an air-gapped system, you need a system on site that will keep running even when the internet goes down, just these organizational requirements, then I can understand self-hosting, but it's usually not a good idea just to save some money. So to distill everything down, storage cost optimizations are often easier than and more valuable than trying to save on actions. Actions are much less likely to get out of control by accident. Usually the actions that you're doing are unavoidable, or if you can avoid them, you can usually just avoid an action or two. Continue as new is an essential tool, especially if you're going to be running very active workflows or workflows that are going to be running for a very long period of time. It's essential to think about this in your workflow design up front. And then one more thing that I like to throw in here at the end, because it's kind of something people don't immediately think about, is avoid spreading out your work over too many Temporal Cloud namespaces. The Temporal Cloud bulk discounts for actions and for storage costs are only given per namespace. So if you're splitting your load across a bunch of namespaces, you might not be getting the savings that you would otherwise get from using Temporal Cloud's bulk pricing. So make sure you're only using namespaces for necessary isolation of domains, either security domains or organizational domains. Don't use it for semantic isolation if you can avoid it. So armed with all this knowledge that I've given to you over the last 30 slides or so, we go back to our boss and we say, you know what, you needed 10K or so? Not a problem at all. I've implemented a codec to condense your payloads. I've started restarting our history before we sleep, moving a few of our actions from a frequent workflow into a batch. We've redesigned some child workflows to move them as activity batches into the parent. And we've slowed down our signal rates. We've saved 10 grand at least, and it's barely, the morning's barely gotten started. You look at your boss, and he looks back at you like this, and you know 100% you're getting that promotion at the end of the year. But yeah, a day's work well done. It's time to head out and start your vacation. So you and your coworker, I guess, joined you, ready for the beach. Hope this info helps you should that call ever come from your boss, should that meeting ever arrive. Thanks to everybody who helped me edit this talk. If you'd like to see a follow-up blog post going into any of these, showing some code implementations, please let me know. Either just reach out to me on LinkedIn or send me an email. I'll be doing a Q&A in the hall after this for anybody who has questions. I'll be posting the slides to the Bitovi Discord, and you can always reach out on there to hassle me if you've got questions as well. Thanks for attending.